Hi friends, my name is Tris, and this is No Boilerplate, focusing on fast, technical videos. Today I'm going to make some web service recommendations, mixing some of my favourite Rust crates together into something that I use across most of my Rust projects. We'll start with the hardest problem in computer science, specifically that acronyms don't always make the words you want them to. I'll just call what I'm using the stack, and let you come up with your own name if you like. The stack I'm going to talk about today isn't the best stack nor the most fully featured or fanciest. It's my favourite stack. It showcases what Rust is great at, and it focuses on correctness above all else. Everything you see in this video, from the script to the images, are part of a markdown document available on GitHub under a public domain license. So let's talk about what we're not going to be doing with a counterexample. Web.py is one of the many gifts the late great Aaron Swartz gave us. It's elegant in its simplicity. But we are not building simple tools. Today we are building guaranteed correct tools. Python, and by virtue web.py, can't give you these guarantees. Lots of things are just strings, and the language can't help you with compile time checking very much. Luckily, we have Rust. I have some crates that I use in nearly all my Rust projects. This feels like my own personal standard library. There are options for all of these. If you would prefer anyhow to Air or EVCXR to iRust, you can't go wrong. I'll explain some of them briefly. Air, pronounced like the book, Jane Eyre, or the result variant, result Air, is a fork of the ubiquitous anyhow crate, a trait object-based error type for easy, idiomatic error handling, but Air allows customizable error reports, which is exactly what Color Air hooks into. Install Color Air, as shown, and enable the Rust backtrace environment variable, and it turns this normal-looking Rust error, which is functional but boring, into a full color traceback. Runtime errors are dreadful in any language, and with Rust they are nearly always avoidable. However, there are cases where unrecoverable errors happen, and when they do, you will want Color Air. The whole README of Air is wonderful, by the way, and you should read the entirety of it. I love Bacon, and if I'm coding Rust, Bacon is always open, running Clippy by pressing C after launch, even when I'm editing in an LSP editor. There's nothing clearer than rustc's output, and when I'm coding, I need my conversation with the compiler to be as clear as possible. Tracing is Tokyo native logging. Everything's in Tokyo. Web servers, HTTP request crates, parallel processing libraries. You might as well start off with a logging handler that is great at async logging. My stack doesn't explicitly include Serde or Tokyo for the same reason I won't be telling you to type with a keyboard or execute code with the CPU. It's a prerequisite of using the other crates, so we don't need to go over them. I'll show you SQLx actually working when we build our API in a moment, but it is so alien you'll need to start processing this now. Here's the gist. SQLx allows the same structs you build the state of your program with to validate your SQL queries at compile time. Got it? I'll pin my deep dive testing video if you would like to watch that too. Finally, the meat of the stack. Poem came to my attention in 2022 as I evaluated the Rust web framework landscape. There's a lot of really great options. Now, I'm going to have to talk about benchmarks in this section, so I need everybody to be chill, okay? Okay. I have included all Rust frameworks alongside some fast and slow other frameworks. I discounted unpopular languages and frameworks. This included NIM, C++, and a lot of others that aren't relevant. You'll never persuade your team to use them, so you won't be using them. Popularity matters. That's why Rust is exciting. I used these synthetic benchmarks to get a feel for if any Rust frameworks were going to hold me back when scaling. And the answer is no, not really. As we all know, speed often isn't very important, but if you can have it, you might as well get it. To illustrate this, look at the bottom of the graph, at our old friends Express, Sinatra, and Flask. If this were a popularity graph instead of requests per second, each of these mature frameworks would eclipse all above them. Our industry has decided that they are fast enough, and who am I to disagree? Looking at the top of the graph, to be fair and balanced, I have included the two fastest Java and JavaScript frameworks in the world. These are obscure, rely mostly on native code tricks, and are still only just edging out the Rust pack, despite both Java and JavaScript's literal trillions of dollars over decades in optimization. Very interesting. So, my search led me to this speedy part of the universe, Rust frameworks that were all benchmarking at well over 100k, putting them amongst the fastest on the planet. After looking at them all, I fell in love with Poem, and specifically their first-party REST API plugin, Poem OpenAPI. Let's look at it. Here's a simple plaintext endpoint, mounted at /hello. We have our top-level struct that we hang handler functions off. The OpenAPI macro surrounds this, adding lots of boilerplate that we don't care about. The OAI macro converts these simple functions into OpenAPI handlers behind the scenes too. Then we have the handler functions with validated inputs, in this case just one echo handler. And the query type guarantees safe matching of query params at compile time. No ad this episode, thanks to my patrons, and before we build our API with Poem, I'll briefly tell you about how this is possible. I have quit my day job and am now making videos and podcasts full-time, supported by my wonderful patrons and channel sponsors. Thank you everyone for watching and supporting me along this wild ride. On my Patreon, there are various levels, but all get early ad-free and tracking-free videos and access to a private section of my Discord server. By the way, did you know I run a huge Discord server? Over 2,000 lovely people chatting about Rust, music, mental health, and other cool stuff. Now that I'm doing production full-time, I've increased the number of slots on the new mentoring patron tier to 25. I can teach you anything I talk about on my channel. See the pinned announcement video for details. If it's fully booked, message me on Patreon or email me and I'll add you to the waiting list. Let's build. First, as always, we start with the data model. These first two structs define both the database and API interface into our data. The third is a top-level POEM OpenAPI struct that we hang our API interface on. We'll see the implement blocks for this in a moment. Binding your database and REST interface together at compile time allows us to have extreme confidence in our data integrity. This is a superpower. If you define your API in Rust structs, the compiler will stop you from breaking the contract with your API clients. Not only that, but if you don't see a PR where the structs change, your colleagues and collaborators haven't broken the contract either. Huge! Now we roll into the implement block for our to-dos API struct. Our handler functions are defined here, with our database pool being passed in as the first parameter and the post body as the second. This first function creates our to-dos and handles a post to /todos. The return type is the integer ID returned by the database, wrapped in JSON. Next, we define the getAll handler, also mounted at /todos. The database pool is passed in here too, as it will be automatically on all our handler functions. It's passed in by the router, as we will see in a moment. You can see the return value here is our to-do response, a vector of to-do structs wrapped in JSON. Now we're using SQLx's compile time verified query to pull our to-dos from the database. Note the parameter before the SQL query. That's our to-do struct, the same that is used to define the items in our REST interface. If I break the query, watch what happens. SQLx caught my incorrect SQL query by connecting to my local database, in this case SQLite, at compile time. This SQL error comes from the Rust compiler. SQLx taught the Rust compiler to understand how to connect to a database. Black magic, right? I have a video that explains what is happening here, called Rust's Witchcraft. Let's finish up with the POEM config in our main function. That's a bit much. Let's just focus on the function body. First, we set up our connection pool using SQLx. This is configurable but has sensible defaults. SQLx supports Postgres, SQLite, MySQL, and MS SQL. If you have the choice, you should use Postgres. Next, we're building the POEM OpenAPI service. Note we've passed in our top-level to-dos API struct, which has all of our handler functions implemented. Next is a friendly name for the API and a version number that is exposed to our API clients. We then build an instance of the OpenAPI Explorer frontend. This is a built-in UI for POEM OpenAPI and isn't the only one available. POEM also supports Swagger UI, Rapidoc, and Redoc. Here's what our OpenAPI Explorer looks like. Of the UI options bundled with POEM OpenAPI, OpenAPI Explorer looks best to me. They're all built off the same OpenAPI spec that is built from your handler functions automatically. Note that this is all derived from your structs. Unlike in other languages, there is no need for separate API configuration here. The rich type system captured so much of the interface to our data that it can be auto-generated. Back to the main function. POEM's router is very straightforward. The route is initialized using the builder pattern, adding routes with the nest method, the first parameter being where it is mounted, and the second, the handler function of the API. This is the top-level organizational unit of your app. Think of large namespaces like login, user, or search. You then build loosely coupled API structs that define their own URL namespaces under them. Lastly, the data method attaches state to the endpoint. This is how you share state between your handler functions. The most common use of this pattern is to share in a database connection, as we are doing here. And finally, we start the POEM server, connecting the routes that we just defined. We did it! A simple post and get interface with an auto-generated prototyping UI and documentation. What about the front end? That's a topic for another video, but I have opinions here. Though there are many templating libraries and markdown processors, and even a really great pug-like library called Maud, I don't dig these. For me, Rust code is your templating system. Functions and modules are your unit of abstraction, and it's all type-safe. RSTML and U provide RSX-style HTML all checked by the Rust compiler, having been programmed by macros in these crates. That's the basics of my recommended stack. Work with Rust's type system and you'll be rewarded. Put all of your logic from the data to the API right up until the HTML into the hands of the type system, play with it with immediate feedback from Bacon, and you'll be writing production-grade fast code quicker than you ever thought possible. Thank you. If you would like to support my channel, get early ad-free and tracking-free videos, VIP Discord access, or one-to-one mentoring, head to patreon.com/noboilerplate. If you're interested in transhumanism and hope punk stories, please check out my sci-fi podcast, Lost Terminal. Or if urban fantasy is more your bag, do listen to a strange and beautiful podcast I produce called Modem Prometheus. Transcripts and compile check markdown source code are available on GitHub, links in the description, and corrections are in the pinned ERRATA comment. Thank you so much for watching. Talk to you on Discord.